Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we are going to learn about greedy method and the control abstraction. This topic you'll find in unit 2 as topic 5. So generally control abstraction means the general method where you can apply on several problems. So let's understand what is greedy method and what is the general method, how I can apply greedy method on problems. We'll see it now. So what is a greedy method? Greedy method is one of the algorithm technique to solve computational problems. There are many techniques as far as to apply on some computational problems to find a solution, and those are divide and conquer method and brute force method, greedy method, dynamic programming, backtracking, branch and bound. What all these are? These are different techniques to solve many computational problem. So greedy method is also one among it. Now, if I wanted to apply greedy method on the problem which have n inputs and require us to obtain a subset that satisfies some constraints. Any subset that satisfies the constraints are called feasible solution. And the feasible solution, what we need to find that either maximize or minimize for a given objective function is called as optimal solution. Now, how greedy method will be applied on a problem is greedy method basically applies on in stages. That means in each stage we'll find a solution. The greedy method suggests that one devise an algorithm that works in stages, considering one input at a time. Now, look at the general method of greedy method. Let's see. I have taken a comma n. The mean of a comma n is a is an array with n inputs. So initially the solution is what? 0, because I didn't find any solution. I wanted to find the solution after I select each item from the array. Now let's take some example. I am taking some array of numbers 1, 2, 3, 4, 5. Now to find out the solution for this problem, what we'll do is we'll take each number for I is equal to 1 in the sense what? I am selecting one element from the array and that element I am giving into x. Now what is my x? X is what? My solution. Okay. Now, so x is a variable where I will be storing the feasible solution into it. If I am considering this 1, if it is my solution, then if it is my feasible solution, then I'll put into x. Now I'm checking whether feasible solution is x, then we will add the feasible solution with the operation of union. Among all these 5, maybe all 5 are not feasible solutions, maybe all are feasible solutions. If it is the case that all are feasible solution, what we'll do is one by one solution we will keep into this solution. And once after we found whichever solution is optimum, then that solution will return. We'll take some example to show you. Now, so what we did is at each stage, a decision is made regarding whether a particular input is an optimal solution or not. This is done by considering the inputs in an order. Determine some selection procedure. If the inclusion of the next input into the partially constructed optimal solution will result in an invisible solution, then this input is not added to the partial solution. And that's what we were seeing in this algorithm example, right? So when you are given with some number of inputs to check which are feasible solution, we'll check one by one. If it is feasible, then we'll add into the solution. If it is not, then we'll skip. The index will get increased and we'll take the other number, we'll add into the solution. We'll take some real-time example that I'm taking some change making example. Let us assume that there was a boy who wanted to buy some chocolates from a shop. Now he's having 10 rupees with him, but the chocolate cost is only 3 rupees. So what he'll do is he will give this 10 rupees to shopkeeper. Now what shopkeeper will do? Shopkeeper has to return him back with 7 rupees. Okay. Now this is what your problem. Problem is what? When he wanted to give 7 rupees, how can he give? So he can give all single pennies or single rupees, all single rupees. It is one feasible, because feasible is what he has to return 7 rupees. So it is one feasible. And also he can give 2 rupees coins of 3 and 1 rupee, 2 rupees coins of 3 and 1 rupee coin is 1. It is also feasible. And he can also give 2 rupee and 5 rupee coin. He can also give 5 rupee and 2 rupee coin. Anything is possible, right? So whichever solution is possible, that solutions are called as feasible solution. Now, what is optimal solution? The optimal solution is what? When the result gives maximizes or minimizes, then that is optimal solution. The result of a particular problem, either it should maximum or it should minimum. Then as far as this example is concerned, what is the constraint what it shopkeeper has to follow? If it is a constraint given that he need only 2 coins, then what shopkeeper will do? Shopkeeper will take one optimal solution, which is 5 and 2. So let us make this is 2, 3 and 1. And now look at this, 5 and 2. So this solution, one of the feasible solution. If a solution is said to be optimal, it has to first of all feasible. Then only it can be a optimal solution. You can have number of feasible solutions for a problem. As far as this change making is considered, you have 4 feasible solution. But optimum solution always will be one, only one solution. The solution which gives you maximize or minimize. So now as far as the count of the coins are considered, these coins are 7 maximum coins. These coins are 4. These coins are 3. These are 2. So if you wanted to select a maximization, you will select this. So then it will become optimum solution. If you wanted to select a minimum result, you will take this. Now it becomes a optimum solution. This is what greedy method. Now we'll take the other example. Now the other example is what? Let us assume that a person wanted to travel from one city S1 to S2. Now the problem is what? Traveling. So when he wanted to travel, there are many ways of transport to travel. Either he can have a bus or walk or a bike or car, train or a flight. All these are feasible solutions. Correct? All these are solutions. Now, which are feasible? The feasible solutions are, if he wanted to reach the particular S2 city in the time of 3 hours, then he cannot go by walk. Correct? He can choose bus, he can choose bike, he can choose car. Now these are what feasible solutions. Now what it is optimum solution? The feasible solution which gives a minimum either minimum or maximum result. So maximum result is what? If I wanted to reach that in with the cost of low, with the minimum cost, then we will choose flight. If it is the maximum cost, we'll choose bus. So this is what actually greedy method. Now one more point we have to keep always in the mind. The problem which can be have constraint, that the constraint is feasible solution. The feasible solution which reach to the maximum or minimization, that is called as optimization problem. Now, a problem is a optimization problem which requires minimum result or maximum result. Then that problem is called as optimization problem. So, optimization problems can be solved using greedy method, dynamic programming and branch and bound. So greedy method will complete in stages as I told you in the just before slide. If it is feasible, then we will include. If it is not feasible, then we will ignore. So this is what actually greedy method. You can take many examples here. So buying a car or recruiting an employee into your office. So when you wanted to buy a car, you will not buy blindly, right? You will check with different models based upon your parameters. You will check all the models. You will check each solution is feasible or not. If you have something like Hyundai car, you'll think about it whether it is feasible or not. So the feasibility is always calculated based upon the constraints. The constraint may be a mileage, the constraint may be a petrol or diesel car, the constraint may be how much, good the engine is. All these are the constraints. Based on these constraints, you will have some feasible solutions. And based upon the cost, if the cost is minimum or maximum, then it is one optimization problem. So greedy method is what? It solve optimization problems. So as far as the this unit is concerned, we'll be going to have optimization problems to solve. The next video will be going to solve knapsack problem, right? Thank you all.